All right. So, a few announcements, which, as you can see here, and also, this is actually the public service announcement from last year, but the information still seems to be good. This is another one of the HKN offers this service that you can use, any number of services that you can use. I just make sure that you're familiar with them. And you can see, you can go off their webpage and see more if you'd like. We will, just to remind you, Project Zero has been released. Homework 2 has been released. These things are available. The waiting lists are now empty. So everybody who was on a waiting list is now not on the waiting list. Now, you may have been stuffed into a lab or discussion section you can't make. However, we don't really care which lab or discussion section you go to, so find one that works. Let me remind you that there have been a couple of new lab and discussion sections opened up, and you might, for example, take a look at those. So look at the schedule of classes should contain all of that information. We will be holding additional homework parties and so for homework parties and guerrilla sections in the future, do keep an eye on Piazza about that. Also, for those of you who encounter bugs in your program, again, let me make this plea. For those of you who encounter bugs in your program, it's not usually very effective to post these things on Piazza. Sometimes it is, because sometimes you'll encounter a bug whose symptom happens to be the same as what somebody else encountered. But very often, at some point you should decide that you want to get us to look at the actual code. And when that happens, we have this command, bug submit, described on the class webpage that does that. So that sends mail directly to us so that we can, or at least directly to me, so that I can process it if necessary. Okay, and finally, those of you who are having any kind of setup problems at home, such and such a command doesn't work, such and such, especially if you're on Unix or Mac. On Windows, we sort of expect that things won't work and suggest that you just SSH into the labs and do things on the instructional computers. But on Mac, Linux, and Unix, our software should run just fine. And if it doesn't, it probably means you have some kind of configuration problem, installation problem. And really, it's much better if you get it fixed, because you'll save yourself a world of hurt. We've been telling you not to use SCP or the equivalent to schlep files back and forth. What you should try to use, if you're on Mac or Linux, is the homework command, which will safely put files into the repository with a homework commit, and homework update is the download command that downloads things from the repository. So your usual sequence of work is, I'm working at home, okay, I've come to a reasonable stopping place, or I've got something that compiles, so I'll commit it, and then you work a little more, okay, I guess I've done a little more progress, I'll commit that. And then you find yourself in the lab or something like that, so you say, okay, I'll get the changes that I got from home. I do homework update, get the changes that I got from home, and so forth. So please, that should make sure that you don't have too many difficulties. Now, you'll still get into difficulties. I see people do things like they erase some file and then they add it again. They have a file that's already checked in, they erase it, and they say, oh, I better add it again. And no, don't do that. That will cause confusion. We've already had to fix a few errors like that. So there is a fix homework command that basically it comes with documentation that says if you use this command more than a few times, it means you're doing something systematically wrong, and you should probably consult somebody about it. but it basically will, it's basically I mean what I say command. You say this homework directory seems to be broken at the moment. I can't commit. Please make it so that I can commit. And it basically throws away all of the old information, puts in the new information, and continues. And you continue from there. So you can use that if things get broken, but you should aim for never having to use that command. Because it is an indication that something has gone seriously wrong. Okay, enough of the blather. Questions before we begin? Anything in particular? You can always send me mail saying that such and such a point is terribly obscure to me. Could you please do something about it in lecture? And I'll usually try to work that in if I get these things enough in advance. All right, so just a quick review. We're going to talk today about arrays. This is another kind of these objects that are anonymous objects that get pointed to. And this particular kind of compound container, structured container, has a length which you can't change. It's the length of the array. And it has a bunch of boxes or cells or whatever you want, simple containers that are numbered from 0. And those are their names, 0 through whatever. And the thing that's different about this, as compared to, for example, int list, is that you can compute the value. You can compute what label you're going to fetch from. So in int list, it's not as if you say, it's not as if you can have, well, you can, but only by very indirect means. It's not as if you have a variable whose value is head, and you say, apply this function of the int list object and head and get the head value. No, it doesn't work that way. You don't compute you don't compute the name. You actually write it out in the program. But with arrays, you can compute them, and that's what makes arrays very interesting. So these are just like lists. These are very much like lists in Python, with the exception that that the length can't be changed. You can't expand or contract them. All right. So, but otherwise, they're like other structured containers, which is to say, they don't have names. Instead, you have pointers that point to them. So anything that you think of, if you have an array A, what that really means is that A is just a little box that contains a pointer to this structured object. And again, the important feature of these arrays, the interesting feature of them is that the index, the name that you use, can be any integer expression. All right, so I have a few samples. Now, I'm going to show them here, and then I'm going to take a look. I'm going to venture a look with the debugger just to show you how you look at arrays in one debugger anyway. So we introduce a couple of variables that are of type array, int bracket bracket, x, y, z. This is, for those of you who know C and C++, this is a different kind of syntax for arrays. The C and C++ syntax is actually allowed for array declarations, but is discouraged or deprecated, at least in my view. But this makes it very clear. So x, y, and z are arrays. And A is an array. Also, it's an array of strings. And in this code, I will first of all create a new array with 3 elements in it and stick that and get x, give x a pointer to it. And so initially it will contain 3 zeros. And here I've made y and x point at the same thing. So when I say y equals x, it doesn't make a copy of the array. It makes a copy of the pointer. That's actually the universal rule. When you have an assignment, it makes a copy of the value. And if that value is a pointer, then you get a pointer. You don't get anything else. You have to be explicit if you want something else. I've created a new array of strings, which start out as empty. And I'm putting, and in this particular case, I'm doing a couple of manipulations. I set the second string of A to hello. I then change elements 1 of both x and y, and as you'd expect, the effect of this is that the value of x1 and y1 becomes 3. So then we have another piece of syntax down here. This is the syntax right down here with Q, that for creating a new array as an expression. So you have one expression, new int, bracket, bracket, and then the integers, which creates a new array with 3 elements in it and initializes them. If you have a declaration, you can actually get rid of this annoying new int, bracket, bracket, and just say this in the declaration. But that syntax doesn't work. That syntax won't work elsewhere. All right, so is there anything obscure in this diagram? If not, I'll do a quick demo of what happens when we run something like this through the debugger, or code like this through the debugger. So here I have in one of these directories, if I can find it, I have, yes, EG, for example. Okay, so let's make things a little bit larger. Well, maybe that's a little too large. I don't know. I hope that's big enough to see. And I would like to. So I actually have this compiled. Let's see what happens when we actually run the debugger over it. For those of you who don't have much experience with the debugger, so we can start the debugger with gjdb metax gjdb of, and in this particular case, the command is not double even magic. No. That's something you're not supposed to see. It's the class name, EG, not eg.java. Okay, so if we look at this, if we go back to the original code, well, let's start this program. So what I'd like to do here is I'd like to stop on the first line of the program. So I'd like to stop at the first line where we actually do something, which happens to be right here. And so the debugger lets me do that in a number of ways. This is called setting a breakpoint. If you're in Emacs like this, the convenient thing to do is to simply say Control-X space, and that sets a breakpoint right at that point, as it says. I could also have written this command that you see down here in the auto buffer at the bottom. I could have said simply, I could have alternatively said down here, if I can get down to this. Oh, I see. Always getting my fingers in the wrong place. I could alternatively say break on line number 5 in EG, and which would have the same effect. But I think you'll usually find it more convenient to just set it by the position in the buffer. So let's get rid of that second breakpoint since it's a little bit redundant. Now, if we run this program, the run command, what happens is, it says it didn't find the class? Oh, my goodness. How terrible. Sure enough. You're absolutely right. Okay. So I'll just change the class that I'm running. All right. And I'd better remember to start the thing properly next time. Oops, I guess it did not believe in keeping this breakpoint around. You think I'm what? No, that doesn't make any difference. It's the class name that matters in this particular case. So it says main method not found in Yeah, that's the problem. You're right. You have found the error. All right, so let's just recompile this sucker and see if this helps any. Okay, so we'll run it again. There we go. Okay, so now the thing breaks, and it's pointing with a not very visible pointer, unfortunately, on the Mac. It's much more visible on the downstairs machines. It's pointing at that first definition. Now there's nothing there until I go to the next step, which I can do with the n command, and also with there's also a function. There's also one of the function keys that will do that for me. And what this does, so I've now gotten just past the assignment to x, and I can look at that array x. If I ask to print what its value is, it tells me that its value. It tells me that it's an instance of a three-element array. That's what it says down here at the bottom. So x is, in fact, let me spruce this one up a little bit. So it's telling me that x is an instance of an int 3. In other words, it's a three-element array. It's not telling me anything else. It would be kind of nice to know what's in this array. And for that, I can say, okay, when you print a pointer, print for me the thing that pointer is pointing to. So this I do by saying p/1, which means follow one pointer. So in other words, if there are pointers inside that, I won't follow them, but I will follow one pointer to see what the array is. So now if I print the array x, I will see that it prints as an array, 0, 0, 0. All right, so now I will go down to the, let's execute this next statement, n. Right, execute y equals x. Now if I print y, what we see is that it's also an int 3. Now in this particular case, and for those of you who are really observant, you'll notice that the thing that tells us that x and y are the same variable, the same array, not different arrays, but the same array, is that you have this little notation here at the end that says so. It says that this is an array. It has an internal ID, that is to say, we're going to call this array number 419. And look at this. This down here is also array 419. So they're two different. They're actually the same array, which means that when I go down to the next, when I get down to the next statement. So I go down one more statement. Let's see what's up here. So I go down to past a equals new string, and I will go past the, what is this? Oh, I see. So I've gone past x1 equals 2, and now I'm on y1 equals 3. So if at this point I print y, I'll see that it contains a 2, even though it was x1 that I set, but of course x and y are the same array. So you actually get y as a result. And we can continue in this fashion. So we'll continue for a few more. At this point, we'll see that p/1 of x, the whole array x, contains of 3, as you'd expect. And when I go past, at the moment, a /1a contains a bunch of nulls, but after I execute this next statement here, it contains and hello and so forth. That's actually a pointer, but with strings it's kind of convenient to just represent them as a string, because otherwise you'd be chasing pointers all over creation, and that's not so nice. All right, so that's just a little illustration of the debugger in action on arrays to show you that you can look at the contents of an array And you can, in fact, well, that's not all. We could even do something else inside this thing. We could say, set the variable a sub 0 to say O or OH. And at this point, if we now print that array, we actually have changed the array. So that's you don't often do that inside a debugger. It's just sort of nice to know you can. Occasionally, you will be in a program and you say, "Gosh, you're doing some obscure piece of debugging and you just want to change a variable," and the debugger will actually allow you to do that if you really feel like it. All right, so here is the canonical go through the array and do something with each of the elements without changing it. So here's the canonical. I'm sorry, were there questions on the preceding stuff? I should look up. Yes.
So if our GJDB debugger is stepping through the code, but we can't see the arrow actually step through it, how is there a command so that we can see it?
Well, you actually can. It's not very visible from here, but you actually can see the arrow. You just have to look very, very carefully. There's this little bump on the side of the display. I should look to see whether that can be improved. It seems to be a feature of this particular version of Emacs. And if you run this on the instructional machine, what you'll find is that the arrow is much more prominent. So yeah, if you try it on your Mac. You have a Mac, I see. Try it on your Mac, and you'll see that there actually is a little indication there. It's just a little bit. It's a little bit hard to see. So I'll see what I can do about working on that, but I can't promise anything because it's in the innards of Emacs instead of where it ought to be. All right. So yes. You mean undo it? No, I'm sorry, not in this debugger. There are debuggers that do that, and it's actually a very interesting problem in engineering design to figure out how to get yourself a debugger that will do that. Now, the Java visualizer, for example, basically runs the entire program and then records everything and then allows you to step through it. That's one technique for doing it. But of course, that has its problems in some cases, especially when the execution goes on for a while. So your traditional debugger, and this is a traditional debugger, does not have a backup. But that's a good question. I've come to a certain point in my code, something blows up, and I say, "Oh, gee, the error must have occurred somewhere before. What should you do?" You can't back up, so what do you do instead? Set a breakpoint where? Right, so you can zero in on the error by setting a breakpoint at some point previous to it. Now, if you read the documentation, it might occur to you that sometimes you're in a loop. And if you set a breakpoint before in a loop, what you'll do is you'll hit the breakpoint the first time through the loop, which might not be the time where it blows up. So, but if you peruse the documentation, you will find that there are actually things that allow you to do something about that, to break only if some condition is satisfied, for example, which you will occasionally find useful. I just put that out here. I'm not going to illustrate it now, but I just put this out here because that's the way people should, you professionals to be, should work. You say, you know that something is possible. It should only be sufficient that you know that something is possible. And when you know it's possible, you should be able to find it. And that's sort of the way it works. That's how I spend my life, finding things that I know are possible, but I don't at the moment happen to know how to do. Okay, so here is the standard loop for going through an array. You'll see this all the time. So you you start, for an iteration, that is, we start at the beginning of the array, or wherever it is that we're supposed to start, the first index. We keep incrementing the variable, the I variable in this case, until, for as long as we are for as long as we're less than the length of A. Right? Why less than? Right, so the array has 0 index, which means that the last element has index a dot length minus 1. Now, this might seem confusing, but you eventually get used to it. And then when you're asked to debug some Fortran program, you get all confused, because Fortran programs, the arrays go from 1 up to the length of the array. But that's okay. But you'll survive, don't worry. You won't see too many Fortran programs anyway. All right, so in this particular case, what I'm going to do is to sum things up is I go through the array, I take each element, a sub I, and I add it into n. Now, this is quite common, and in fact, there's actually, I call it new syntax, but it's actually been around for quite some time now, for just doing something like this without having to do all the indexing. And that is, we simply say, for all values x, all integers x in the array A, which has to be an array of ints, or an array of capital integers, we increment n by x, which is probably a clearer thing to write. The only problem with it is that only applies to entire arrays. So if you have something where you want to just do part of the array, like from 1, for example, or something like that, well, then you have to write the loop on the left, which is somewhat of a pain. In Python, as you remember, you can always use this form, because there are ways of saying the portion of the array that runs from this to this. So go figure. Why are we making you write in this old-fashioned, crippled language called Java when we have this wonderful language Python, which is actually considerably older than Java, to write in? I don't know. It's what can I say? I mean, that's just people's tastes for some reason. Now, this down here, just to sort of strengthen your knowledge of how for loops work, this thing right down here is an equivalent thing, and you can see I've sort of pulled out all the stops down here. So I can you're not restricted to initialize just one thing. You can initialize two things, I and n. You're not restricted to incrementing just one thing. You can increment two things, and then have an empty, have a body that doesn't do anything. Don't do that. It shows how clever you are and how well you know Java, but it's virtually unreadable. So I would avoid it if you could. Okay, so now here we have an example in which I want to insert something into an array. Now, unfortunately, of course, I have a slight problem here, which is that an array I can't insert something into an array without throwing something else away, because arrays have a fixed size. So I've defined this particular insert procedure to convert the array destructively, meaning the original value of the array goes away, and to basically insert something into the array, push all of the values down, and throw away whatever the value is at the end that for which there isn't any room. So, for example, if I insert GNU into this thing over here at position 2, then that is just before Hartebeest, the effect will be as you see on the right there. So this is a pretty straightforward array, but you'll notice I did something a little bit odd down here. I started from the end of the array. So I read this loop, this loop ran backwards. So I started at the end of the array, and I decremented the variable until as long as it remained greater than k. So I start at the end of the array, and I move the preceding element into that element, and I just keep doing that until I get down to the element that I'm supposed to insert, to the place I'm supposed to insert, and at that point I end the loop and I come down here and I insert x into that element of the array. So am I just showing off? Why am I doing this backwards? Isn't that obscure? Have I not just said that I'm not supposed to be obscure? I mean, what is this? I see. Who have I not called? Okay, yes, go ahead.
Because when you put an item into the middle of the array,
Uh huh.
the ones at the end of the array change the distance. The ones at the beginning are affected.
Yeah. But I mean, why didn't I just start from position k plus 1 and go until I equals k plus 1 and go until I is less than a dot length and do the same thing? Wouldn't that work? Yeah.
Because you would take the item at index k, move it to index k plus 1.
Yeah.
Next time you would move that same item to k plus 2.
Right, so just imagine what would happen. I'm here, for example, I'm inserting, let's say, at Gazelle, and so I'm inserting GNU at position of Gazelle, position 1, for example. So I'd come down here, and I'd set Hartebeest to Gazelle, and then I'd come down here, and I'd set Skunk to the preceding element, which is no longer Hartebeest, it is Gazelle. So this is, in fact, doing this forward is actually the classical loop for filling an array with the same value. You put it in the first position, and then you just and then you can repeat it all the way up to the beginning. So in order to do this a little bit, now if you can remember to look into the library occasionally, there is this very convenient method for doing this same thing. This is a general method for copying from one array into another, or even into the same array. You give it the place that you're copying from as the first two parameters. So I'm copying from array ARR, beginning at position k. I'm copying to array ARR, starting at position k plus 1, and the total number of elements that I'm copying is that over there. So it's the difference between ARR.length and k, which is the number of items between k and length, but minus 1 because one of them goes away. So this is a convenient thing to use. Most people, like me, and Josh says he has the same problem, can't remember the order of the arguments to system array copy. But that's one of the wonders of modern documentation systems, is that it's easy to find that documentation. Now, array copy is clever. In a case like this, it knows that, I'm overlapping this array, therefore I have to copy backwards. So it understands that concept. And in fact, if you do it in the other direction, if the first one were ARR k plus 1 and the second one were k, that you have to do forward for the same reason as before, but in reverse. And it figures that out too and does the right thing. So this actually acts as if it makes a copy of the part of the array it's supposed to copy, puts it aside, and then copies it in, so that you don't get this overriding effect. Okay. So suppose that I do want to grow an array. In that case, I have a routine like this. So in this particular case, what I'll do is that I will have my array A. This is a non-destructive operation because what I'm going to do is create a new array that's one element longer than the old array. And then I will copy the first part, everything up to the first k elements, I will copy from the original array into the new array. So in this particular case, I'm doing insert A2 A2 GNU, which means that I will copy these two elements, bear and gazelle, over to here. Then I will copy these two elements, hartebeest and skunk, into here. And then I insert GNU at the end and return the result. Now, there's a difference here. This one, I have void inserts into the array. This one, I return the value of the array. Why don't I just say down here at the bottom, ARR equals result? Yeah. I am creating a new array, and right. Excuse me? That's right, but can't I assign into the ARR value? That doesn't modify the original array. It changes ARR to be this new value. It throws away the old pointer and puts in a pointer to the new array. Why wouldn't that work? Why couldn't I then not return anything, just have it change the array? Pardon me? That's right, the new array is local. In other words, this variable here, ARR, is in fact a copy of the array, of the pointer to the array A. And changing a copy of the pointer does not change the original value of A. So this call here, no matter what I do to ARR down here, this call will not change the value of capital A. A will still have the same pointer as before. It can modify the value of the object that A's value points to, that stood in the house that Jack built. Right? It can modify that, but it cannot modify the pointer itself because it's a copy. Right? So you're only working on copies. So that is, again, Java does what we call call by value. You make a copy of all the parameters, which does not mean that you copy the objects they point to. Now, if you think that I'm banging on that subject too much, I can assure you that at least one of you is going to make this mistake in a homework or test. So, so all I'm doing is covering my rear, making sure that when that happens, I will be able to say, I told you so. All right, so let's look at another example of advanced array hacking here, which is what we'd like to do is a very, very common operation, merging. I've got two lists that are already in order, and I want to put them together into a new list that's in order, that contains the elements from both in order. So we say we're merging the two. This doesn't mean that you put one after the other. It means that you intermix their values depending on how big they are. So the two inputs, of course, have to be in order to begin with, otherwise you get weird results. But that's sort of the end result that we want. So I hope everyone understands this operation. It's an extremely useful operation, and we will see a little bit more of it when we get into the algorithms part of the course. You've probably seen it before. Okay, so here is an implementation for you, and I'm just going to do since we sort of like, or I sort of like the recursive model. Let's see what happens when we throw recursion at this thing. So I'm going to, I want to write this merge routine, but the problem is that there's no obvious recursive call I can make to merge here that's going to help me very much. So what happens in cases like that, as often happens in recursive cases, is that you have to generalize the method. You have to make a more general method than this first one that has a few extra parameters that you can use to this purpose. So what I'm going to do is, because after all, what's the recursive operation going to do? It's going to do a merge, but on part of an array, just part of an array. So why don't I do this? Why don't I have parameters that tell me which part of the array? So I've defined a new, more general procedure that merges everything in A, starting at position L0, and with everything in B, starting at position L1. That's a more general routine, and so I call it initially with starting at 0 in both cases. So the first thing I have to do is figure out how long the result is going to be. Well, the result is going to be the distance between L0 and the end of the array and L1 and the end of the array and the end of the second array. So it's going to be the sum of these two sizes. And then we proceed in the usual recursive fashion. If L0 if we've already used up all of the elements in A, then the next element that we put into the array is going to be, then the next element that we're going to put into the array is just going to be into the array C, the result that we're looking for here. We'll just put all of the elements from B into that, and we'll be done. Otherwise, if B is already used up, then we'll just copy all the elements from L into C, into the result array. Right? And then finally, the other two cases depend on, is the first element of L less than or greater than the first element of, is the first element of A to be copied, to be merged, less than or greater than the first element of B. And if it's less than, then the first element of C will be the first element of L0, and then we copy, and then we will copy the rest of the, we'll copy the result of merging the rest of the array A into the rest of C. So we merge everything from L0 plus 1 onward with everything in B, and we copy that into the result array C, starting at position 1, and likewise down here. Now this is a nice clean solution, but it's a terrible solution. It's really bad. Not because it doesn't work, but for another reason. What's wrong with this solution? Any objections to this solution? One objection, only one objection. I find it highly objectionable, but I guess that, yes? Yes, that's true. You can always have this problem of overflowing the stack. There's another even more serious problem, however, that becomes even when you don't overflow the stack. Yeah. Right. So you're copying arrays all over the place. I mean, look at what you do here. We copy all of the elements from. We're basically, this statement right here is going to perform the whole merge operation on the rest of the array, and then throw that result away after copying it into C. And you can imagine that this happens for many recursive calls. And in fact, what I have done is basically to take an operation that ought to be very fast, ought to be proportional to the size of the two arrays together, and I've turned it into an operation that's a great deal worse. So one way to do this, to approach this, is to generalize still further and to say that my merge operation, I will give it the two arrays that I merge, A and B, and the starting points in those two arrays. And I will also give it the array that I want them to assign into, and the starting point in that array. So that means that, for example, in this case, I would have L0, I'd have L1, and I start at location K and assign into C like that. Right? So that obviously allows me to do this. So if I had that with me, what would I do? So first of all, so suppose that L0 is greater than or equal to A dot length, meaning that we've already used up all of the elements in A. What should we do what should we do to finish the program? In other words, how should I replace this question mark thing? So again, I've used up everything in A. I'm supposed to be merging A and B into C. So what would go there? Yeah. So you're going to say C is assigned what? C sub... well, we could assign C to B, but of course that has the same problem I had in the previous problem, which is assigning to C does not change the parameter that was passed in by the caller. Pardon me? Yeah, well, that's all right. That's right. We have to modify C. So exactly how would I modify C right here? Yeah. That's right. So we could just do the array copy of everything in B into C, everything remaining in B into C, and likewise here. So these are actually the same. Problems as the same statements as before. We copy everything from B into C, everything from B into C, starting at position K, everything from A into C, starting at position K. And this one, what would we put in for this one here? So I set C sub K to L sub 0, and what's the next thing that happens? These calculus students just can't shut up, can they? No. Pardon me? I think I heard the right answer, but it was murmured, so I couldn't quite catch the... You think that you can outweight me, that I will show you the solution here in my... No, I will leave you hanging. You say, if you won't help me, then I won't help you. Yeah. Turnabout is fair play. Nobody, huh? Okay, well, I win. We'll see you on Monday.